Good morning, student. Today we are going to do an experiment of VLSI lab. So the aim of the experiment of today's experiment is develop a VHDL test bench code for encoder circuit. For that, equipment required are Xilinx IAC software and personal computer. So encoder. Digital encoders produce outputs of 2-bit, 3-bit or 4-bit codes depending upon the number of data input lines. An n-bit binary encoder has 2 to the power n input lines and n-bit output lines. So today we are doing an experiment of 8 to 3 encoder. So 3-bit output lines, that means input is 2 to the power n, so 2 to the power 3, that means 8-bit input lines. Okay, so this one is the diagram having 8 inputs, that is D0 to D7, and 3 outputs. So we can give name as per our convenience. So here it is given Q0, Q1, Q2. I can also give the name X, Y, Z or ABC. So see here in this table, this one is the input side and this one is the output side. So in the first row only D0 bit is 1, D0 0, then the binary value of 0 is 0 0 0, that is given here. Then in the second row only the D1 bit is 1, so the binary equivalent of 1 is 0 0 1. Then in the third row only D2 bit is 1, the binary value of 2 is 0 1 0. Like that up to D7 means 7, the binary value of 7 is 1 1 1. So we write as per this format. Then what is the equation of this output equations? So output equation are, that is here we can take output as x y z. So x equal to, only this part is 1, so we have to only mention that 1 values, means here when here it is 1, at that time D4 is 1, when it is 1 D5 is 1, like this only 1 values we have to mention. So x equal to D4 plus D5 plus D6 plus D7. Then in the y, these are the 1. So here when 1 is written, in the same row the 1 is present only in the D2 column. Then at this point the 1 is only present in D3. So only we have to write the values of 1. So y equal to D2, D3, D6 plus D7. Like this, the z part only write the ones. So the equation is z equal to D1, D3, D5 and D7. Okay, so these equations are only declared in the programming, like x assignment operator D4 or D5 or D6 or D7, like y assignment operator D2 or D3 or D6 or D7. then Z assignment operator D1 or D3 or D5 or D1. Okay, so this is all about theory part. Next we will do the experiment. So for the experiment, first we have to click on this icon. After the opening of this window, here click OK, then go to new source and select VHDL module. So today we are doing the experiment of encoder, so here I gave the name encoder. Next, the inputs are, as this is a 8 to 3 encoder, so 8 input names are to be given, that is D0, D1, D2, D3, D4, D5, D6, D7. Okay, 8 inputs, then 3 output, that is X, Y and Z, and here we have to change it to out. Next, finish. Then here we have to declare the functionality, that is X assignment operator D4 or D5 or D6 or D7. Then Y assignment operator D2 or D5 or D2, D3 or D6 or D7. Then Z assignment operator D1 or D3 or D5 or D7. One second. So the program is complete. Right now we have to save it, then click on check syntax. So here you can see green tick, that means there is no error present in this program. Next, view the RTL schematic. Okay, click OK. This one is the schematic, that is having 8 inputs and 3 outputs. Then double click here. This one is the internal diagram. Here you can see 3 OR gates are used, each OR gate having 4 inputs. So first one is the D7, D6, D4, D5, and second one is D7, then D6, then D3, D2, and last one is D1, D3, D5 and D7. Okay, next we Again click on the new source and select VHDL test bench. So encoder TB. Next, finish. Then change the option here, that is click on simulation, then change the programming as per our requirement. Means there is no requirement of clock period, so delete this, then delete all these things, then define the inputs here. So D0, as we have to declare 8 combinations for input. Okay, so D0 assignment operator 1, D1 assignment operator 0, D2 assignment operator 0, D3 assignment operator, D4 assignment operator 0, D5 assignment operator 0, D6 assignment operator 0, D7 assignment operator 0. So first input combinations is declared here. Next, here I write a wait option, that is wait for 20 nanosecond. Okay, so here the first input combination where D0 is 1, then in second input combination D1 is 1, in third D2 is 1, in fourth input combination, in fourth input combination D3 is 1, in fifth one D4 is 1, sixth one D5 is 1, in sixth one in seventh one D6 is 1, in the last input combination D7 is 1. So here D7 1, here D6 1, D5 1, D4 1, D3 1, D2 1 and D1 1 and D0 1. Then we change the timing in wait statement. Here 20 nanosecond, then 40, 60, 80, 100, 120, 140, last one 160. Then check the behavioral syntax. Here green tick is showing, that means there is no error present in this programming. Then click on simulate behavioral model. So drag the pointer and keep on any position. So see here, D5 is 1. So the binary value of 5 is 101. Correct? Then change the position. Here D3 is 1. So here at the output bits, that is X, Y and Z, this one is the binary value of 3, that is 0, 1, 1. So as per the waveform, our programming is perfectly working. So this is all about 8 to 3 encoder. Thank you.